Bob Lazar, element 115.
Element 115, the fuel they had, was stable. In other words, it didn't decay. It wasn't emitting radioactivity. When they synthesized 2 or 3 atoms of the 115, it did decay.
(100) 115. Bob explained that half a pound of stable isotope of element 115 was used as the fuel. In about 10 years after his story, this element, isotope named moscovium, was synthesized and its half-life was 0.65 seconds. Bob suggests that natural isotope could be different, in number of neutrons. Another explanation possible. When particles and atoms are formed, they encapsulate time of the environment. Some of them can have very slow time canned inside. See chapter 11 for example of billion to trillion times slower time in particles. If time in where and when this element 115 was created was billion times slower than our time, then lifetime of it increases from 0.65 seconds to 20 years, and if it was trillion times slower, then lifetime increased to 20,000 years. Where is such time and place, with billion to trillion times slower time? Whatever we see around us has had 12 times slower time at most, and it comes from the past, and currently slow time in galaxies' centers and around heavy stars called nearly black holes. But that's about it in our neighborhood. But CMB, cosmic microwave background, see chapters 11 and 5, corresponds to billion trillion times redshift, time dilation. So, it is either from ancient times or from the outskirts of our universe. The ancient times version is not valid, because even with 20,000 years of the element half-life, the element would have decayed by now. To support outskirts of our universe version, we need a delivery method that covers billions trillion of light-years distances from there to Earth in less than 20,000 years, meaning traveling faster than light, but not violating sea limit. That craft capability we discussed in the previous chapter, and physics of it is still intact despite it sounds fantastic. Next puzzle about element 115, half pound of it was packing an astronomical amount of energy. That alone contradicts with Einstein's E equals mc squared, is it? Before checking that, let's look at something else called flywheel, ancient and well-known human invention. Even Leonardo da Vinci was improving it. It is puzzling too, and energy calculations there relate to the element 115 energy problem. Flywheel is a mechanical energy accumulator. Here is one used in US school buses since the previous century. Nowadays, modern ring-shaped flywheels made of carbon fiber rolls and running in vacuum are installed on top-notch racing cars and more. Let's start far away. Say we have an object of mass m, moving at a speed v, it has energy ev equals mv squared / 2. If the speed v is high, it is difficult to change it, even for a small change of speed delta, because change of the energy delta E will be big. V delta. Delta E is a big number even for a moderate change of speed delta when V is a large. Let's explore similar problem for a bus with a flywheel installed on it. Changing speed or direction of the bus when flywheel is packed with energy and rotates at a very high speed. Let's say Say all points A1, A2, B1, B2, C1, C2 have same mass m before bus start moving. Energy of these points is 6mv²/2, but we will see that it is easier to track energy in pairs, opposite one another with the will center in between. When bus was not moving, energy formulas were when bus has speed delta, energy changes. To calculate general case for points C1 and C2, I moved velocities at these points to the right on the picture above. This created a parallelogram, so the longer blue arrow's length by power of 2, by Pythagorean theorem, is h² plus d plus delta squared. Squared. And the shorter blue arrow's length by power of 2 is h² plus d delta squared. Initial velocity v in power of 2 is v squared equals d squared plus h squared squared. So, EC1 EC1 plus EC2 equals delta EC1 plus delta EC2 equals mh² plus md² plus m delta squared 2m d² plus h²/2 equals m delta squared. Energy of all pairs change by m delta squared, and for the whole wheel that results in delta E equals mw delta squared/2. Where mw is the total mass of the wheel, and the division by 2 comes from pairs, number of which is half. We have just confirmed that the energy canned in high RPM flywheel, high speed V, does not contribute to the bus inertia, energy change mw delta squared/2, otherwise it would be a collision hazard. The wheel weight does contribute to the bus inertia. This problem is solved in racing cars installations, where light carbon fiber flywheels are used instead of heavy steel. Back to the element 115 with time inside slowed billions trillion times. In frozen candle puzzle, we saw that for an external observer everything inside a slow time zone is hardly moving. For billions trillion slower time that means even electrons' moves and other particles' vibrations become non-relativistic. I wonder if quantum physics, which is 100% statistical, because it describes greater than 10 superscript 10 velocities and less than 10 dash superscript 10 space, still works when time slows down dramatically. For us, it is important that these particles' trajectories have central point symmetry. So, we can apply the same math we applied for the flywheel to understand that these atoms and particles' inertia is not impacted by amount of energy packed inside. That explains why half a pound of element 115 with slow time inside, meaning packed with energy, see chapters 4 and 8 for more, can be carried around, literally half a pound and not tons. Classic bus with flywheel model shows that a bus at rest can encapsulate various energies. Similarly, an atom at rest can have various amount of energy, it can pack very different time, and particles inside the atom can pack various times. That challenges E equals mc squared paradigm of rest mass and energy equivalence. There is no rest in nature, in theory only. To my knowledge, physics of slow time has not been developed yet. Let's try figuring energy formula for a slow time out of two well-known formulas. Relativistic energy formula, E equals mc squared, 1v slash c squared dash 0 middle dot 5, 1. Doppler shift formula, Z plus 1 equals 1 plus V slash C 0 middle dot 5 slash 1 volt slash C 0 middle dot 5, 2. From 2 we can get VC equals Z plus 1 squared 1. Z plus 1 squared plus 1, 3. Substituting VC and 1 with the right side of 3 gives us E equals MC squared, 1. Z plus 1 squared 1 squared. Z plus 1 squared plus 1. For brevity, I will use symbol D instead of Z plus 1. Then foreshortens to E equals MC squared, D squared plus 1, 2D equals MC squared, D plus 1 slash D, 2, 5. Where D is time dilation. Of course, formulas above are for an object moving in a straight line, and they are not about a non-moving object at rest, like delta E greater than mv delta formula was for a straight movement, and not for a flywheel. Formula E equals mc squared should be more like E equals mc squared d squared, 6. When we talk about energy encapsulated in an atom at rest, because measurements are in second dash squared, and time in the atom can be d times dilated compared to the current time. Astronomical factor d squared explains half a pound of stuff containing an astronomical amount of energy. For more details read Free Beyond Cutting Edge with Bob Lazar at .play.google.com or at Amazon.com. Bob Lazar, Gravity and Strong Force. Bob explained that gravitational forces around the craft were generated out of gravitational forces inside element 115 atoms by amplifying them from an atomic to a regular scale. To his credit, he does not name this atomic force as strong force, as it is called in mainstream physics. Let's debunk strong force first, as we debunked dark energy at the beginning of the book. And then we will reinstate Bob's statement in more clear terms. As always, time dilation plays Occam's razor role. Mainstream physics states that protons and neutrons are pulled together into a nucleus of an atom by a force overriding repelling electric forces between positively charged protons. This atomic force is called strong force, the strongest in universe. It is 100 times stronger than electromagnetic force, and 1038 stronger than gravity, but it weakens fast outside nucleus. But if that was true, then nothing would prevent neutrons coming together, some of them randomly decaying into protons, which never decay, and all of them still kept together by that magic force. Then heavy elements would be in abundance, and even more, many atoms would be as huge as neutron stars. But luckily, there is much simpler and more universal explanation. Droplet of slow time holds protons and neutrons together. It is not particles attracting each other by an extra and very strong force. It is particles trapped together in a slow time spot. Page 33 explains how high energy slow time, when displaced by an object, results in lowering energy of the system. The drawing at page 22 gives an impression about such spot. Chapter 2 describes boost, and chapter 8 describes time energy. Time dilation, or redshift z, at the border should be big, not to let these particles escape. And perhaps because such areas are dense in energy, they are small and have an atomic/nucleus/particle scale, there might be nested levels of time slowness, particles formed at even slower time than nucleus and atoms. Small radius, and/or high curvature of the border, limits an acceleration path allowing escape, if influenced externally or bounced internally. Now, it really reminds gravity, which is just a gradient in time dilation. The only difference is in the order of magnitude. For example, time dilation around Earth is of 10-9 magnitude, time dilation in spiral galaxies is of 10-cubed magnitude, except in galactic centers, where it is higher. In element 115, to gain its stability, time should be dilated at least 10 superscript 1 squared order of magnitude. That is why such atoms are rich source of time. And it could be dilated even more. Now we can see what Bob Lazar meant by gravity from element 115, atoms was amplified to the surroundings of the craft. It was about time dilation at atomic scale and time dilation around the craft. For more details read Free Beyond Cutting Edge with Bob Lazar at play.google.com or at amazon.com. Bob Lazar, Joules and Energy Conservation. Throughout the book I was avoiding quantitative formulas for many reasons, but the main reason was the fact that variability of time makes many units and constants not constants at all. For example, a deadly acceleration, which is measured in m/sec squared, becomes not so deadly if time speeds up. Or, as I mentioned, Einsteinian popular formula E equals mc squared does not sound right when time of an object is d times slower than the time of the environment. In this case, it should be more like E equals mc squared d squared. Why? Second is unit of measure used in number of seconds context. Second that I use throughout the book is duration, or length of a second. Number of seconds and duration or length of a second are inversely related. Second 1 per second because of Einsteinian and Maxwellian speed of light constant. Second is the time it takes for light to travel 299,792,458 meters. You can think. Second 299,792,458 meters per second, and since 299,792,458 meters is a constant, we have second 1 per second that explains how 1 per second which is used in acceleration measurement. Joule, energy unit. Gravitational constant G Planck constant H. Can throw quantitative formulas off and draw some physicists to wrong conclusions. Let's focus on Joule, J equals kg square meter/sec squared. When a particle was created in an environment, its energy was E equals mc squared. Time canned in the particle has a speed of second particle and time of the environment has a speed of second space, and there is no reason to believe they are the same now or eventually. Since this book proves that space-time speeds up, let's denote by d the factor that measures how much time is sped up since the particle creation. Second particle equals d second space. Energy E equals mc squared was canned in the particle and measured in joules at the creation, with joule particle equals kg square meter/sec squared, second particle, squared. But if we say that in our time with second space, the energy that could be released from this particle is still E equals mc squared, then we are wrong, because this number for us is measured in joule space, where joule space equals kg square meter/sec squared, second space, squared, second particle, d squared. The released energy is d squared times less than the original, a violation of conservation of energy principle, despite the fact that the number mc squared is still the same. It is like 100 pounds and 100 kilograms are the same in number, but are actually different. Because of this, the formula E equals mc squared should include the time dilation inside the object. E equals mc squared d squared. Since we measure in joules that are d squared times less for us now. In the nutshell, energy packed at one time and unpacked at another time should be the same actually, but not necessarily numerically, as the unit of measurement of energy joule might have changed. If your grandpa bought a house for $2,500 long time ago, and now you sell it for $250,000, then the price change is because of dollar, unit change mostly.